A relation is a set of ordered pairs. A relation can be shown in a variety of ways. So below we have a table, a list, a graph, and a mapping diagram. Here's our table, which we are used to seeing. So the age in years is our X, and the height in meters is our Y. We take this table and we can turn it into a list of ordered pairs. So you just take each pair and put it in parentheses with a comma. So this is 17, 4, 16, 4.5, 20, 5.5, 12, 5.0, and 16, 6. Now, the domain of a relation is the set of all of the X values, while the range of the relation is the set of all of the Y values. So another way to show the same relation, we have the table, we have the list. We can also graph the ordered pairs. So we can graph. Remember that you start at 0, 0. You do the X value first by moving left or right. And then you do the Y value second by moving up or down. So the first one, we start at 0, 0. We're going to go over 17 and then up 4. Start at 0, 0, over 16, up 4.5. Then we have 20, 5.5, 12, 5, and 16, 6. This is our mapping, which we've talked about before. Remember that the mapping needs to be done in order. The domain we said were the X values, and the range were the Y values. So we can take it straight from here, from the table, put those in numerical order. So the domain would be 12, 16, 17, and 20. Even though 16 was repeated, I'm not going to repeat it in my mapping. And then I'm going to do the range, again, in order. So 4, 4.5, 5, 5.5, and 6. And then we map how they are connected. So 17 is connected to 4, so we map 17 to 4. 16 is connected to 4.5, so we map 16 to 4.5. 20 maps to 5.5. 12 maps to 5, and 16 maps to 6. A relation that only has one value in the range for each X value in the domain is called a function. Is the relation above a function? And the answer to this is no, it is not a function. Why or why not? It is because you have this input of 16 that outputs to two different outputs. This is like pressing a button on the vending machine and getting two different things come out of that one button. So that is not a function. There are two outputs for the input of 16. Now we are going to identify a function given a table. So first we are going to find the domain and range, and then we are going to decide if it is a function. So the domain, remember, are the X values. That's going to be the first thing, the first column, the first row, depending on what kind of way the table is set up. And the range is the Y values. So our domain here, remember we use our curly brackets, 3, 5, 8, and 9. And then our range, 27, 45, 72, 81. And then we can do a mapping. Again, put these numbers in order. So our domain was 3, 5, 8, 9. Our range, 27, 45, 72, 81. 3 maps to 27, 5 maps to 45, 8 maps to 72, and 9 maps to 81. So is this a function? Well, we need to look at our inputs, our domain, and do any of these inputs go to multiple outputs? And the answer is they do not, so yes, it is a function. Another way that's easy to look at this is to look at the domain. Did any of these numbers repeat? None of those repeated, so this is a function. Now would be a good time for you to pause the video and do the understanding check. So if we look at our understanding check in part A, you are supposed to list the domain and range, and then it asks if any of the domain values repeated. So do any of these X values repeat? And the answer was no, none of them repeated. So is this a function? Since none of them repeated, yes, it is a function. In part B, they asked you to make a mapping. So if you go ahead and map everything, you notice that when you press button number 3 on the vending machine, it's going to give you 2 different things, which is not okay. So this is not a function. In example 3, we're going to use the vertical line test. So it says find the domain and range of each relation and use the vertical line test to determine whether each relation is a function. So first we are going to go ahead and graph these ordered pairs on our graph. And then, like we talked about before, we're going to put our pencil down on the paper vertically and pass it through the graph. So you're going to just go over the graph, keeping it straight up and down. And we're trying to decide if it passes through 2 points at the same time. And the answer is yes, it does right here. Yes. It passes through the 2 points 3, 0 and 3, 2. 3, 0 and 3, 2 at the same time. So a function will not have 2 points in a vertical line test. So this graph is not a function. Because my pencil touched 2 points at one time, anytime it touches more than 1 point at a time, it is not going to be a function. So this was not a function. So go ahead and use the vertical line test and do your understanding check. So let's go ahead and check your answers from the understanding check. Here's the mapping. And is this a function? Yes. If you look, none of the domain values, none of the inputs have multiple outputs. They all only go to a single output. So every time you press a button on the vending machine, you are only going to get one thing coming out. Now when we look at part B, if we look at this mapping, when you press that button on the vending machine of -2, you are going to get 2 different things to come out whenever you press that button, and that's not okay. So this is not a function. Another easy way to look at this is to look at this table at the domain, at the X, at the input, whatever value you want to call it, and see if any of the values repeat. Well, -2 repeated, so this cannot be a function. Now we look at a list, so we have a list of ordered pairs. Again, you just take the X values, these are going to be your domain values. So we have all of these X values in our ordered pairs, that would be the first number in each ordered pair. We're going to put those in order, 11, 12, 13, and 20. Then we have all of our Y values, which are the second numbers in the ordered pairs. If they repeat, we are not going to write them multiple times in the mapping. So I'm going to have -2, -1, and 7. Well, 11 maps to -2, 12 maps to -1, 13 maps to -2, and 20 maps to 7. So is this a function? Some of you might be thinking, no, it's not, because the -2 is repeated. But it is okay if it repeats in the Y. So yes, it is a function. This just means I pressed 2 different buttons, and both of those buttons gave me the same thing. That's okay. The only time it's not okay is when you press one button and get two different things. And then part B, we just list the domain. So we use our curly brackets. All of our x values again, -2, -1, 6, and -2. So I'm only going to write that -2 once. And then we have the range. So that would be -1, 0, 3, 1. Is this a function? Well, did any of our x values repeat? We had -2 and -2. So since the x value repeated, no, this is not a function. Go ahead and pause the video and do your understanding check. So now we look at our understanding check, part A. Run your pencil across the graph in part A. Does your pencil ever touch more than one place on this line at the same time? The answer is no. So yes, it passes the vertical line test, and it is a function. Part B, if I pass my pencil vertically, look what happens. It's touching here and here at the same time. So it does not pass the vertical line test, and it is not a function. C, it looks good at the beginning, and then you get towards the middle, and notice that it touches in 3 different places at the same time. So that cannot be a function. Part D. You pass this, it looks close, but there are never more than one point touching my pencil at a time. So this is a function. So for the rest of this, you have one last page, which is your homework to be completed for tomorrow.